So we are going to do 1 and 4 together, and you are going to do 2 and 3. So look at number 1. Algebraic fraction. We're supposed to add. So first, we need a common denominator, right? Do we have a common denominator? Yeah. So when I combine this, I get x plus 5y plus x plus 2y. Okay. Now you put those in parentheses to say that, you know, x plus 5y were together and x plus 2y were together before we added them. Okay? Does that make sense? And the plus sign is because that's what was in the middle. So had this been minus, that would be a minus. Now you may remember from Algebra 1 that if there's no number out in front of the parenthesis, you don't need those parentheses, okay? Because there's nothing to distribute. So I have x plus 2y. And when there's a plus sign outside parentheses, basically you're distributing a 1, which keeps it the same. So you could just write that as plus x plus 2y. And it's all over 25y cubed. And then here you must combine like terms when you're adding and subtracting, because you're going to combine like terms, look at the fraction, and then simplify if you can. Yes?
So you want to look at 5?
Yes, yes. I was looking at that. So thank you. That should be a 5. Good thing I wrote in pink, because green goes over pink. Okay. All right, so looking at the numerator, what combines in the numerator? X and x makes, x times x makes x squared. X plus x, when you have 1x and 1x makes, when you have 1x and another x, how many x's do you have? 2x. And then when you have 5 y's and 2 y's, how many y's do you have? 7. Now after you combine fractions, you look at them and you go, all right, 2x plus 7y is your GCF? No. 25, I could break that into 5 and 5. Y cubed, I could break that into y. But there's nothing that's going to cancel. So it is simplified. Correct? So this is my final answer. All right, number 4. And I'm going to have to put the factoring on a different piece of paper. There's really not much space to work here. So, see the minus? Right? Common denominators. So I could write this. Can I cross what out? Can I just cross these out? Well, first of all, they're on the same, right? They're not numerator denominator. Second, like if you had 1/2 minus 1/2, you wouldn't cross out the 2's, right? All right, so when we combine this, I get n minus 2, and then minus n minus 3, and then my denominator stays the same. Now I cannot just jump to that step if the denominators were not the same. Okay? Now n minus 2, there's nothing out front. Most of the time I never put parentheses around the first terms because you're just going to drop them anyway. So n minus 2 is just going to stay n minus 2. And then here, what does a negative sign do when it distributes? Change the signs, right? So that's going to change that from a positive m to a negative m, and from a negative 3 to a plus 3, right? So that's the key thing kids forget when they subtract, is that it's going to change the signs in the numerator on the second fraction. Bring down this one. Combine like terms. What's m minus m? 0. Do I need to write 0? Not when I'm adding and subtracting. And what's negative 2 plus 3? 1. Now here's where it gets tricky. I personally believe that no matter, even if you were to factor the denominator, it's not going to cancel out the 1. So I would just leave it like this. However, a lot of times on the AccuPlacer, they keep everything factored as much as possible. Okay, so because I know nothing cancels, I personally think that is an okay answer. But on the AccuPlacer, they may factor that. Okay, because the GCF is what, 6m squared, right? And so that would leave here an m, and here a plus 6. And had there been an m plus 6 up here, it would have canceled. Had there been any m's by themselves, they would have canceled. And had there been a 6, things would have canceled. Okay, so like I said, technically this is fine, but on the AccuPlacer they tend to write it like this. Okay, that is your final answer, yes. Okay, so what I want you to do yourself is try 2 and 3. Okay? And when you're finished with 2 and 3, just to kind of give you an idea what it looks like, okay, you should get something like those answers. Okay, so go ahead and try it out yourself.